Okay, for this problem we have this differential equation, dy dt is equal to y cubed. We're going to solve this and also find the domain of the solution if y of 0 is equal to y naught. Before starting, we note that this is not a linear differential equation. It is a differential equation, it's ordinary, it's first order, but it's not linear. Therefore, we have no knowledge as to what the domain of the solution is. We know that there exists a solution. We know that the solution, there's going to be some interval containing 0 that the solution exists, but we don't know how far it goes. Okay, now this is a separable differential equation, so I get that dy over y to the third is equal to integral of dt. Just bring the dt up and the y cubed down. Now notice that I divided on this step, so let's not forget that when we get to the end of the solution. Let's integrate. So negative 1 over 2y squared is equal to t plus c. So if I take the reciprocal, I get negative 2y squared is equal to 1 over t plus c. Let's divide the negative 2 down. So y squared is equal to 1 over, okay, negative 2 comes down, so negative 2t. Then if I multiply the c by negative 2, that just stays an undetermined constant c. And then take the square root, I get either plus or minus, depending on the initial value, 1 over c minus 2t. And so that is my solution of this differential equation. Okay, now let's use the initial value. We know that y of 0 is equal to y naught. So if I plug in plug in 0, I get my initial value y naught. That's going to be equal to plus or minus 1 over c, square root of 1 over c. Okay, now to solve for c, let's square both sides. So y naught squared is equal to 1 over c, and therefore c is equal to 1 over y naught squared. Okay, so that brings us to our solution that y is equal to either plus or minus square root of 1 over 1 y naught squared minus 2t. And so that's our solution. Or is it? This is what happens. This will be the solution as long as y naught does not equal 0. If y naught is equal to 0, then we've got a problem. At this very first step, we divided. So that means that we have this, the very first step, over here, y cubed was divided down to the left-hand side. So there's a second solution that y might be identically equal to 0. That's also a perfectly valid equilibrium solution. And we'll notice that if we come down here, 0 is not found by just simply plugging in something into y naught here. This would be the limiting case as y naught goes to infinity, but we don't get so as y naught goes to 0, the limit would go to this, but we don't get y naught is equal to 0 identically by plugging in any non-zero value in for y naught. So we have two categories of solutions. Y naught is identically equal to 0 if the initial condition y naught is equal to 0. If the initial condition is not equal to 0, then it's plus or minus. And more specifically, it's going to be the positive one if y naught is greater than 0, and it'll be the negative one, I forgot the square there, minus 2t, if y naught is less than 0. Now, for the purposes of the exam, simply saying this and this are the solutions is going to be perfectly fine. But the important point is that we had to be careful that we identified this case here because I would lose a solution if I came out the other end if I just simply divided and carried out the integrals. Okay. Also, to determine the domain of the solution if the initial condition is y of 0 equals y naught. Okay, so clearly here the domain of the solution is all real numbers. Over here, the domain is a little bit more thoughtful. So the domain We're good here as long as the thing underneath, as long as the thing under the square root is positive. So that means that the denominator has to be positive. 1's already positive. So if the denominator is positive, that makes this fraction positive, which means that the square root is defined. So the domain is going to be that 1 over y naught squared minus 2t has to be greater than 0. Can't be equal. If it was equal to 0, then it'd have 1 over 0. That's not permitted. So that means that 1 over y naught squared is got to be greater than 2t, so that t is got to be less than 1 over 2y naught squared. And so therefore the domain we can write as anything to the left of 1 over 2y naught squared. And as expected, as y naught goes to 0, this approaches infinity, and I would get the entire real line. Okay, so the moral of the story is that the domain of the solution of an initial value problem can depend on the initial condition if the differential equation is not linear. If the differential equation is linear, then we have some theorems that say that the form of the differential equation allows us to predict where the solution is defined. For a nonlinear case, all bets are off, and we actually have to do the solving before we can find the domain of the solution.